Let's start with the basics. Please explain what a cryptocurrency is.
A cryptocurrency is a currency that is driven by computer code. It's also sometimes called an algorithmic currency. But rather than being issued by a government, it's issued by a computer network with code that is usually very transparent so that people can understand when coins will be created and at what rate, and how they'll be stored and so forth. So you're putting your faith not in a central bank, but in the integrity of the computer code itself. So you can see the rate of money creation, which is very different than a central bank, which uses its judgment but will change it from time to time whenever it ultimately concludes that it should. The way it began is still something of a mystery. We know that late in 2008, somebody using the name Satoshi Nakamoto posted a white paper on a cryptography bulletin board on the internet. And at first, almost nobody noticed this except a small clan of people who frequented these kinds of places. But the ideas spread by word of mouth, and volunteers helped Satoshi code this up. It went live on January 3rd, 2009, and Satoshi Nakamoto vanished after a couple of years. We still to this day don't know who this person is, but they haven't been involved in the project since sometime around 2011, 2012. Strong number two in the market right now is called Ethereum. But Ethereum is internal to the Ethereum blockchain, and it's used just to execute smart contracts within a closed system. So some people would call Ethereum not even a currency, but a token, since it's a single-use type of asset. But there's no question it's valuable, that lately Bitcoin's total market value has been somewhere in the neighborhood of 65 billion, and Ethereum's has been trending between 20 billion and 30 billion. So a lot of people put value in these.
If he wants to do this in a way that's decentralized, which is, Bitcoin's original point in the spirit of things like BitTorrent, it's actually a very hard computer science problem to figure out how to do it. And Satoshi Nakamoto probably came up with the first solution that, really is practical in this kind of open permissionless context, which is, the Nakamoto blockchain. And that was where the idea of blockchain technology in general came from. Now, where Ethereum comes from is basically you take that idea, the idea that you can use what I call cryptoeconomics, so a combination of cryptographic algorithms, things like hashing and digital signatures, and the kinds of economic incentives that keep systems like Bitcoin going, and use them to create these kind of decentralized networks with memory, so these kind of decentralized database-like things for a whole bunch of other applications as well. Right, so around 2013, people started realizing really that these blockchains are usable for much more than peer-to-peer digital currency. And the first major thing aside from Bitcoin was probably Namecoin, which was trying to do a peer-to-peer decentralized DNS. But then people started thinking, can you do other kinds of digital assets? Can you do smart contracts? Can you do financial agreements? Can you do registries about identity? Can you do all these other things?
I think it's a new type of property, and exactly what regulations might apply to it is far from certain, and you'll get different answers in different countries about that. A blockchain is simply a database, but it's a very different type of database than we've historically used for financial data. So typically you would have a ledger with debits and credits and a balance sheet with assets and liabilities. It's a whole system of double entry bookkeeping that came in during the Renaissance and has been really for 600 years the backbone of capitalism. The blockchain is totally different. It puts records into a sequence and it links them together using something called a hash code, where if you change one entry in the ledger, it throws off all the future entries. What this means is that it's very easy to spot fraud, much easier than in double entry bookkeeping, in fact. So blockchains not only are very transparent in that you can see when they've been changed, but typically with these cryptocurrencies, they distribute a copy of the blockchain to everybody, which allows you to crowdsource the auditor function. So it's not just that a mistake would be obvious if somebody changed the ledger, but everybody on the network would be able to see it at once. You wouldn't have to rely on an auditor, investigator, whatever to find it. You would see it in real time.
And there are so many applications that building a blockchain for each one doesn't really work. And so the core idea behind Ethereum is, you can have a general purpose blockchain. We can have a blockchain where instead of the blockchain working like a Swiss Army knife, where you have 5 different tools for 5 different categories of applications, you have a blockchain that understands a general purpose programming language. So, kind of like your phone, in your phone you have Android or, iOS. And inside of Android or inside of iOS, you can have apps. The apps are written in whatever programming language they're written in. Anyone can create an app, anyone can download an app and run it. So that was the kind of general purpose flexibility I was trying to bring to the blockchain world.
Basically, anything tracked on a database can probably be tracked more successfully on a blockchain than on the databases that we've used for a long, long time. So blockchains hold out the promise of defeating cyber fraud and hacking, of making international payments much simpler without all the levels of credit checks and redundancy and so forth that have to go into that. The Economist magazine called the blockchain a trust machine because the cryptography is such that you can unconditionally rely on it once it reaches you at the customer level. So it has the potential to really revolutionize financial markets.
Yeah, so I think there's a few major categories. So, anything to do with the currency itself is obviously going to be a major category pretty much forever.
Because you want the security associated.
Yeah, exactly. Currency seems to be naturally the kind of application that's fairly well suited because the general way that I categorize applications that are good blockchain applications is to think of what a blockchain is, right? So the way I define a blockchain is it's a decentralized system that contains some kind of shared memory. And in Bitcoin's case, the shared memory is how many Bitcoins everyone has at some time, but it could be anything. So a good blockchain application is an application that, number one, needs decentralization, and number two, needs some concept of shared memory.
Any financial transaction could be recreated on a blockchain at potentially greater security, more savings, faster transmission, all kinds of benefits that have been long sought after in the financial markets for a long, long time.
And the case for decentralization in cryptocurrencies themselves, I think, is fairly clear, but you can actually even go beyond that, right? You can think about, if you have decentralized cryptocurrencies, then you can build many other things on top of them.
And the blockchain probably dates from 1991, seems to have been the first time it was really proposed and discussed. And the authors of the original paper imagined it as a registry for intellectual property, like recording ownership of digital tracks of music and things like that. And it wasn't until 17 years later that Nakamoto wrote his paper and proposed putting these Bitcoins onto blockchains. And this turns out to be the first compelling use case where blockchains were really applied on a large scale, was for Bitcoin. And all of the 1,100 other currencies that have imitated Bitcoin each has its own blockchain. And this is essentially an architecture, a data structure that seems to be in many ways superior to what the world has been using up to now.
The kind of direct control here is important, right? It's not a computer program that makes a recommendation to a guy about how the guy should control the digital asset. It's a computer program that controls the digital asset. On Ethereum, you can literally send a bunch of Ether into a computer program, and once you've done this, the computer program itself has basically the unilateral ability to control where the money goes.
I think it's a matter of time. It's not a question of if, but when a country will do this. And my expectation is that the benefits will be so large that all of the other countries will quickly follow suit, that 10 years from now, you'll see many central bank digital currencies like this.
So now, obviously, if you're going to replace all of these different systems, you have a scaling issue. You have to figure out, especially with a centralized mechanism like that, even just to handle Visa's throughput, let alone every imaginable smart contract, that's not going to work if everyone's running a copy of every program on their computer.
Yeah, totally. So, if you look at just the raw numbers of blockchains today, Bitcoin is currently processing a bit less than 3 transactions a second, and if it goes close to 4, then it's already at peak capacity. Ethereum, right, over the last few days, it's been doing about 5 a second, and if it goes above 6, then it's also at peak capacity. So, on the other hand, Uber on average 12 rides a second, PayPal several hundred, Visa several thousand, major stock exchanges tens of thousands, and if you want to go up to IoT, then you're talking hundreds of thousands.
Supply chain management, logistics, managing the flow of collateral and letters of credit among banks that secure goods in transit, settling trades on the stock exchange. These are very big markets and applications that can probably be done much better on a blockchain than they're done with the old technology that's in use now.